All right, so let's describe the difference between permutations and combinations. Permutations, this is when we're talking about differing the number of ways we can arrange objects. So we typically have some larger group, we pick some smaller, some number out of that larger group, and we arrange them. You know we're talking about a permutation, so you can use, this is NPR on the calculator, or NPR, or PNR rather, if we're using that notation. You know you're talking about a permutation if you see the word arrangement or schedule or order, something that implies that, if you rearrange the things, you would count it separately, then we know that order matters. With combinations, combinations are what we get when order does not matter. We know we're talking about combinations. If you see the word group or committee, a set or sample, basically if you don't care, if you say you do Bob and then Charlie versus Charlie and then Bob, if you wouldn't count that as a separate counting, if you wouldn't count them separately, then you know order does not matter and means you should be dealing with combinations. But you're still starting with a larger group and picking some smaller amount out of that larger group. So both of these, you're starting with a large group and picking some small amount out of them. The difference is whether or not you care about the order. So let's address these ones. For the following problems, tell whether permutations or combinations should be used to solve the problem. How many 4-digit numbers are possible if no digits are repeated? So we're saying no digits are repeated, which means we're taking the digits. So just a quick reminder here, digits, there are 10 digits, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Those are the 10 digits. And if we're saying no digits are repeated, then basically we're saying we're taking 4 of these digits. And you're not going to have a 7 and a 7 again. So we're just picking 4 of the digits. And the question to tell if these are permutations or combinations is, would it be different if you had, let's say, we're talking about a code here, would 0, 1, 2, 3 be different from 1, 0, 2, 3? Now, if we're talking about a code, I would say that these probably would be different. So I would say order matters. So this would be a permutation, because order matters there. A sample of 3 light bulbs is randomly selected from a batch of 15. How many different orders, or how many different samples are possible? All right, so we have 15 bulbs, B1, B2, B3, all the way up through B15. We're picking a sample of 3 of them. Let's say B1, B2, B3. Versus, let's now to figure out if order matters, would we count this separately as if we had B2, B1, B3? Since we're talking about just taking a sample, then that kind of implies that these 2 would not be counted separately. So I would say order does not matter here. It doesn't matter if you pick the first bulb, then the second bulb, then the third, or the second, then the first, then the third. They're the same bulbs. I would say order does not matter here. So we're talking about a combination. I guess if you're interested in what the numbers would be here, this would be 10 and PR4. This would be 15 and CR3, or 15 choose 3, if you want to write it using that notation. In a baseball conference with 8 teams, how many games must be played so that each team plays every other team exactly once? So this one's a little bit more tricky. But I would actually say, if we're thinking about this, we have 8 teams. So let's go team 1, whatever, I'll just call it 1 through 8. 1, 2, 3, 4, 5, all the way up through 8. If we were talking about a particular game, we're saying, a game would typically constitute 2 teams. So maybe the teams 1 and 2. To address whether or not order matters here, we'd be asking, does it matter if it's teams 1 and 2 or teams 2 and 1? Would we count that as two separate games? Maybe 1 and 2 would imply that 1 has the home field advantage, and 2-1 would imply 2 has a home field advantage. So I guess you could make an argument that, yeah, maybe in some situations you might have these counted separately. But this just says the games must be played so that each team plays every other team exactly once. We would not want both of these to be counted separately. So I would say here that order does not matter. And so ultimately we're looking at 8 NCR 2, or 8 choose 2. In other words, the number of ways that we could pick from our 8 teams, the number of ways we could pick a group of 2. All right, and how many ways can 4 patients be assigned to 6 different hospital rooms so that each patient has their own private room? We're saying we have 6 different rooms and 4 different patients. So I'm going to go ahead and say think of the different examples like this. We could go 1, 2, 3, 4. So, you know, the individual spaces here are different rooms. Would we count this as a separate assignment of rooms? So we're still using the first 4 rooms. So the number of rooms, or the specific rooms that are being used, are the same. But we're saying we're assigning patient 1 to room 1, patient 2 to room 2, patient 3 to room 4, patient 4 to room 4, versus here you can say I'm assigning patient 2 to room 1, and so on. Would I count that as a separate assignment? And I would make the argument that, yeah, this would be counted as a separate assignment, because I'm talking about the number of ways that I could assign these 4 patients to the rooms. This would be very different to the individual patients, that, if this person is next to patient 3 or not. So I would say here that order matters. So this would be a permutation. This would be 6 and PR 4. So hopefully this illustrates this idea of whether or not order matters. This is not necessarily always an easy question. Sometimes you really kind of have to think about what it means even to have a different ordering. So in this instance, I kind of had to draw out a different. It wasn't just a matter of drawing out all the different letters and saying a different, picking 2 of them. In this case, I had 6 different spots, and you might have to be a little more creative to figure out whether or not order matters on these.